We're now on the last section of chapter 6, and everything throughout this chapter has been building. We started this chapter out by defining what equilibrium is, and as we continued on through the chapter, we talked about how you can predict whether or not a system is at equilibrium. If it's not at equilibrium, does it proceed to the right or does it proceed to the left in order to reach equilibrium? And then in the most recent section, we talked about how you could calculate an equilibrium composition. So what this section will do is talk about what happens when we disturb equilibrium. And that's when Le Chatelier's principle comes into play. What Le Chatelier's principle says is that when you have a system that's at equilibrium and you subject it to a change, the system will react in a way to counteract that change. With that in mind, let's take a look at an example. Here we're going to consider the equilibrium between 2SO3 with SO2 gas and O2 gas. And we'll assume that this system is at equilibrium, and now we're going to disturb the equilibrium by adding some O2 gas at a constant volume and temperature. And I want you to think about whether that will cause the reaction to proceed to the right, will it proceed to the left, or will there be no change in the equilibrium? All right, so having given you some time to work through this question, let's take a look at what the answer is going to be. So the way that I go about doing this is by writing out the reaction, and then I'm going to represent the stress that you put on the system and how the system counteracts that stress by drawing a series of arrows. So the stress that we're putting on the system is that we are adding O2. And now we have too much stuff on the product side of the reaction. That's the disturbance that we've put in our equilibrium. There's too many products at this point, and so to counterbalance that stress, the reaction will shift to the left. You're going to get rid of that excess of product that you have so that you can reestablish equilibrium. And so the answer here is B. The reaction will proceed to the left until equilibrium gets reestablished. We could take a look at a second example here. We'll think about what would happen if you were to remove some SO2 at a constant volume and temperature. So again, we can write out the reaction, and now what we're doing is removing SO2. Now we don't have enough material on the product side of the reaction. And I'll remind you, right, equilibrium is all about having the right balance of products and reactants. We now don't have enough on the product side. And so this reaction will shift to the right so that you can replenish some of the SO2 that's been removed and reestablish that good balance of products and reactants that you would have at equilibrium. That brings us to the end of this first video that just introduces Le Chatelier's principle. And in our next video, we'll talk about complex systems.